All right, guys, me again. So here's what I'm going to do. I'm going to go through the scenarios where an algebraic application can be applied to these quadrilateral properties. I got parallelogram, rhombus, rectangle, square, which is minimal, and trapezoid. All right, so one by one, I'm going to go through them, and then in an additional video, I'll actually show you the applications played out. So starting off with parallelograms. Since you know that the opposite sides, A, B, and C, D, and AD and BC are congruent, they can give you an algebraic expression for each of the two opposite sides, and you would just set them equal and solve. Piece of cake. Second scenario. Since you know the opposite angles are congruent, they can say, hey, angle A is represented by blank, angle C is represented by blank, you set them equal and solve. Always making sure you're being careful. Hey, are they asking me to solve for X, or do they want the actual angle measure? Scenario 3. Where these two purplish dots are. Okay, fine. These are clearly not congruent. I got an acute angle and an obtuse angle. But what we learned is that the adjacent angles or consecutive angles are supplementary. So you would take the algebraic expression here, add it to the algebraic expression here, set them equal to 180. All right, supplementary angles. All right. And the last scenario for parallelogram is since you know the diagonals bisect each other, they could tell you AE and EC, and you would set those equal, or DE and EB. Now they can sometimes be tricky where they do like AE and AC, where you'd have to double AE and set it equal to AC. Rhombus. Defining characteristic of a rhombus, all sides are congruent. So if they give you any two sides, adjacent or opposite, it doesn't matter, you would set those algebraic expressions equal. Piece of cake. Second scenario. Since the diagonals of a rhombus intersect perpendicularly, all right, they're going to form right triangles for you. All right, so now if they told me the entire length of DB, all right, you would cut it in half because all the properties of the parallelogram still apply. So like if you knew that this here was 12, all right, then you know 6 and 6, you know, and if you knew here that this was 16, then you know 8 and 8. But now all of a sudden, if you have 6 and 8, you can use Pythagorean theorem to find the measure of the hypotenuse AD. All right, plus 6, 8, 10, it's a 3, 4, 5 right triangle. Or like I said, you use Pythagorean theorem. So in that case, that's enough information for you to figure out a missing side of the rhombus. Which, who knows, maybe that goes into figure out the perimeter of the rhombus, something like that. You could also work backwards, where if you knew the side and you needed to figure out a piece of the diagonal. All right, scenario 3. And this only works for a rhombus. So since you know that the diagonals bisect the angles, so like angle DAB is being bisected by diagonal CA. Angle ADC is being bisected by diagonal BD. So that's going to give you these two angles are congruent, as well as these two angles are congruent. So all four of these, 1, 2, 3, 4 are congruent. Same here, 1, 2, 3, 4 are congruent. And in the middle, since they, like we said before, intersect perpendicularly, 1, 2, 3, 4 are always congruent and 90. So you got 1, 2, 3, 4 all congruent the same, 1, 2, 3, 4 all congruent the same, and 1, 2, 3, 4 all congruent and 90. Only with a rhombus. Rectangle. Okay. So the defining characteristic of a rectangle is a quadrilateral that is equiangular, right? So all the angles are congruent and they're all right angles. So if you have a diagonal, a single diagonal that's drawn here, you're going to create a right triangle. So since you know it's a right angle here, again, a squared plus b squared equals c squared. Scenario 2, another big important characteristic of a rectangle. All right, with a rectangle, the diagonals, so this purple diagonal and this blue diagonal, are congruent. So if they give you the diagonals being congruent, if they give you algebraic expressions for the diagonals, you set them equal and solve. Scenario 3, this one's a little tricky. So since a rectangle is still a parallelogram, right? So the diagonals still bisect each other, but since they're also congruent, that whole halves of congruent segments piece from the proofs way back when, that kind of applies. So really you wind up getting 4 congruent pieces. D, E, A, E, E, C, and E, B are all going to be congruent. So where they get tricky sometimes is they can say, hey, if D, E is represented by blank, and then AC, the whole piece, is represented by blank, you would write an equation where you double AE and set it equal to AC. Kind of like what I said before in the parallelograms. Almost done. Square. Square, there's not much creativity to because like pretty much everything's congruent. All the angles in the inside are always 90. All right, since it's a square is a special kind of rhombus, 1, 2, 3, 4 are all the same. And since you're bisecting a 90, they're all for 45s. Same thing here, 45, 45, 45, 45. All right, all four main sides of the square are congruent because again, it's a special kind of rhombus. The diagonals bisect each other and they're congruent because it's a special kind of rectangle, right? So you got 4 right angles in the middle, and you got all 4 of these pieces are congruent, and obviously the main angles are all 90s. So again, like I said, not a whole lot of creativity in a square, but you know, a lot of properties to know. Finally, trapezoid, and generally we're going to stick to isosceles when we're talking about the applied properties. So the base angles, base not necessarily bottom, but the base angles of a isosceles trapezoid are congruent. So you would set angle A congruent to angle B, set congruent to angle B, but also same is true of C and D. So you would set those equal as well if you had algebraic representations. Now, over on this one, what I'm trying to show you is you got the 2 pinkish purple and you got the 2 blue. Well, if you have one of the purple and one of the blue, those are going to be supplementary. All right, so angle A and angle D are going to add up to 180. Same is true of angle A and angle C, all right, or angle D and angle B, or angle C and angle B. All right, so the base angles are congruent, like we said over here, but the other 2 are going to be supplementary. And finally, the diagonals, just like with a rectangle, the diagonals of an isosceles trapezoid are congruent as well. So same situation where you would be able to apply the properties of the rectangle for the diagonals to the isosceles trapezoid because you would be able to set the diagonals equal to each other if given an algebraic representation. All right, a lot of info right there. The second video is going to be the work actually done for you so you can see it applied. All right, have a great day, guys. Miss you. Talk to you soon.